Hey guys, so today we are going to work on some radical expressions and just basically do an overall review for you guys' test that you guys got on Wednesday. So hope you guys are all doing well. Hope you guys had a good start to the week. Hope your sub is, well, I don't hope they're as cool as I am, but I hope they're all right. So we're going to start off, we got 250 radical 3. If you remember how I talked about this, we want to simplify this as much as possible, right? So what I want to do is find two numbers that multiply to get 250. Start off basic. It ends in a 0, so we know 10 goes into it. 25 times 10. I'm going to break this down because I'm going to find the prime factors. And we're going to do 5 times 5. And 10 breaks down into 5 times 2. So altogether our prime factors are 5 times 5 times 5 times 2. That'll give us 250. Now since we have this cube root here, what I want to do is I want to find groups of 3 of the exact same numbers. I found one here with 5. Now for every time you have a group of 3 or whatever it is that you're searching for, I'm going to take one of that number. Now, anything left over outside of the circles that I make and whatnot, anything left over is going to go underneath a radical sign. So, you're going to multiply the numbers in the groups, and then you're going to multiply anything that's outside of it. This will become a little more clear later on when we have more numbers than just 2 numbers overall. So, our final answer here would be 5 radical 2. 5 times the square root of 2. 5 radical 2. Alright, now we got 32. The quad root of 32, k to the 5th, m to the 9th. So, what I'm doing here is I'm going to split these up. Okay. Now, in the end, you can always bring these back together. I just kind of personally think it's a little bit easier to do it this way. So, similarly to when we were doing just normal exponents, I'm going to split up my coefficient in each of my variables. So this whole thing can be rewritten again as the quad root of 32 times the quad root of k to the 5th times the quad root of m to the 9th. Now, I'm gonna split up. I'm gonna find the prime factors of 32. So we got 8 times 4. I guess here I'm gonna write 8 times 4, and 4 can be split up into 2 times 2. 8 can be split up into 4 times 2, and you got 2 times 2. Now, I was looking for the quad root, so I'm going to circle groups of 4 of the exact same number. So we've got 4 2's. That means that the quad root of 32 can be simplified to 2 radical 2. Now k to the 5th. The prime factors of k to the 5th are just going to be k times k times k times k times k, right? Because k to the 5th really means that we're just multiplying k together 5 times. The quad root of this means I'm going to circle a group of 4, and I'm going to keep one of those on the outside. And then everything else is going underneath the quad sign again. So it's going to be k times the quad root of k. Do the same thing with n to the 9th, except for we kind of already know how this is going to turn out, right? So if you notice here, when it was k to the 5th, we took 4, we just subtracted 4 from it, right? And we were left with k underneath the radical sign. So on this one, we're going to, we could do the exact same thing, but 4 can go into it 2 times. So we're actually going to have m squared m. So how did we get this m squared? Well, we know we would have two groups, and we're going to take one of each of them, right? So it would be m times m times m times m times m times m times m. 2, 3, 4, 5, 6, 7 m times m. Alright, so now I'm going to take groups of 4. And I'm going to take one of these. M. Now for each group that I have, I'm going to multiply these together. And then what's left over is going to go in my radical sign. So m times m is going to be m squared to the radical sign. Radical m. I guess it'd be the quad root of m. So now I have 2 radical 2 times k to the 4th, sorry, k quad root of k times m squared quad root of m. I want to combine all of these, so it's going to be 2 times k times m squared, 2 k m squared, and then 2 times k times m. So this over here would be our final answer. Alright, 1,375 t squared. So first off, we know that our final answer, the t squared, is going to still be there because the exponent for t squared is less than our root. But let's look at 1,375. What are two numbers that multiply together to get to that? Well, we've got I could do 5 times let's see, 5 times 2, 75. Alright, now this can be broken down to 5 times 55. And then this can be broken down to 11 times 5. I'm actually going to rewrite this just to make it easier for when we circle things. And we're going to do 5 times 11. So, now, circle group of 3. And we're going to put that on the outside. This 11 is going to go underneath the radical. So we're left with 5 times the cube root of 11t squared. Alright, so hopefully this kind of makes a little bit better picture with those. So you can see down here in the next page we got our answers. If we wanted to add and subtract radical expressions, what we want to see is if they have the exact same base here. So square root of 6 plus the square root of 6 is going to give us 2 times the square root of 6. Now what about this? So 24, and remember the square root is the same as having a 2 up there. So 24 is 6 times 4, and 4 is going to be 2 times 2, right? And 6 is 3 times 2, but that doesn't really actually matter because we got one group of 2 here. So 2 radical 6 minus 2 times, or 2 to the radical 3 times 2, which is 2 radical 6 minus 2 radical 6 is equal to 0. And if you check, our answer is 0. So when you're adding and subtracting radical expressions, it's very similar to what you'd be doing with variables. It's just we're treating what is underneath the radical sign as the variable. So 6 radical 44 plus 2 radical 44, we're going to just add the coefficients, and we're going to get 8 radical 44. So we have 3 square root of 96 minus 4 square root of 80 minus 7 square root of 24. So we know that the square root of 24 is 2 radical 6. So we're going to multiply this by 7. So this back part here is going to be 14 radical 6. But let's look at these other ones. So 6 or 80 is going to be 10 times 8, 5 times 2, 4 times 2, 2 times 2. And we got 4 times radical 5 out there times 4. So this is going to be 16 radical 5. And I don't think, yeah, I was gonna say, I know we can't simplify these parts, but we could probably do this. So this would be 8 times 12, which is 6 times 2, 2 times 2 times 2. It's going to be that one. So we would have these and these two groups. So this is going to turn into 4 I'll walk through this one with you guys. So I don't want to skip anything. We got 8 times 12. 8 breaks down to 4 times 2. 2 times 2. 12 is 6 times 2. 3 times 2. Circle groups. So we've got 1, 2. We got 1, 2. So we're left with a 2 and a 3. So 2 times 2 is 4. 2 times 3 equals 6. So this is 4 radical 6 times. Alright, so now that we simplified the radical parts, I'm just going to rewrite this expression. So we've got negative 3 times 4 radical 6 minus 16 radical 5 minus 14 radical 6 as we found here. So this is negative 12 radical 6 minus 16 radical 5 minus 14 radical 6, which is going to simplify to negative 26 radical 6 minus 16 radical 5. So now, since these are not the same radicals, we can't combine those. If you look here, we got negative 26 radical 6 minus 16 radical 5. So it makes sense. Just treat these similar to how you would with variables and stuff. You can only combine ones that have the same base, and that's what we're doing here. So negative 20, or radical 20, plus radical 20 minus radical 20. What we're left with here is you do negative 1 plus 1 minus 1. So you're left with just negative radical 20. Now can we simplify this? We got 2 times 10, 5 times 2. Now we got a pair here, so let's put it on our outside. So we're left with negative 2 radical 5. And if you look at here, that's exactly what we got. So it's nothing too crazy. When you're multiplying radical expressions, what I would do is, you're just doing the exact same kind of stuff that you were before. So this one here is going to be radical 2 times negative radical 2, which is going to become negative radical 2 squared. Radical 2 squared is just going to become negative 2 plus, this would be minus 2 times 7 and then minus 2 times 7 minus 7 squared. So then we're left with negative 2 minus 2 radical 14 minus just 7. Right, because 7 squared will give us 49. Square root of 49 is 7. So negative 9 minus 2 radical 14. Alright. So a lot of these are larger than what you guys are going to see on the test, but if you're able to do these, you should be perfectly fine for the test that's coming up. So, I mean, I don't want you guys to stress too much, but what I would do is, if possible, simplify the fractions. So, or simplify the radicals. So instead of doing all of this, we know that negative radical 8g can simplify to 8 goes down to 4 times 2. 4 goes to 2 times 2. So we got a pair here. So we got negative 2 radical 2g times 99. It becomes 9 times 11. 9 is 3 times 3. So we got a pair. So it's going to be times 3 radical 11g. Now, multiply the coefficients and you're going to get negative 6. Multiply everything that's inside of here, so then you're left with 2 times 11 times g, which is negative 6, 22g squared. Now, since we have a squared here, it's going to be negative 6. Wow, that is a terrible 6. This is going to go up here. So negative 6g radical 22. If you look at 4, we got negative 6g radical 22. Wow, I'm so smart. They should pay me to do this stuff. Haha. Joke's on you, they don't pay me much anyways. Anyways, let's go on. So, I wouldn't worry about this dividing radical expressions. I don't think we really got into that too much. But if you wanted to, what I would just recommend you doing is breaking it down. So 10 breaks down to 2 times 5, but g squared can be broken down. So it's going to be g radical 10. And if you break this part down, it's going to be 2. So it's 2 times 10. Breaks down to 5 times 2. So 2 over 5 g. And what you'd want to do is multiply top and bottom by the radical. So we want to get rid of the radical on the bottom, right? So to do that, we need to square it down there. So then you're going to have g radical 10 times 2 radical 5g over 2 square root of 5 g times 2 square root of 5 g. We're going to have 4 times 5g, 20g on the bottom. And then we would have 2g times the square root of 5 times 10, so 50g, which really would simplify down to 10g square root of 2g over 20g. And this could all simplify to square root of 2g over 2. Number 4. Honestly cannot believe I got that one right, because it's been forever since I've done this kind of stuff. So, uh, I mean, don't get me wrong, I never really doubted myself, but like, sometimes I do a little bit, yeah. Alright. Anyways, I don't want you guys to worry too much about it. So on these ones here, exponential functions, all you're doing is plugging in these x values and calculating it. And you guys have calculators, you guys can do that. But this one here would be like 7 times 2 to the 7 times 2 to the negative 3 power. So then we're going to do 7 over 2 to the third power, which is equal to 7 over 8. On this one we have 9 times 2 over 7 to the negative second power. This negative flips it, so then it's going to become 9 times 7 over 2, and we could even distribute that. So 9 times 49 over 4. Now we just need to simplify all of this. 49 times 10 is going to be 490 minus 49. So 490 minus 49 is going to be 441. Yeah. 441 divided by 4, which is equal to 110 1/4. Yeah, 110.25. Alright, so you get it, you're just plugging in the value there. Now this last one is just recognizing. I mean, the biggest thing is recognizing these, but you could actually use this to figure out what the equation for the graph is. So, what we're looking for is we want to identify where is the y-intercept. So on this one here, it's at 2, right? So what does the y-intercept tell us? The y-intercept is the point that when x is equal to 0. Alright, so when we're talking about exponential functions, remember our equation is going to look like y is equal to a times b to the x power. When x equals 0, then what that means is that this entire thing here is equal to 1. So if we have a y-intercept, in this case it's 2, that means that a here is going to actually be our y-intercept value. So our equation is going to start off y is equal to 2 times and then b to the x power. Okay, now we need to find out what b is equal to. So what we're looking for is that we know that this is if it is going downwards like this, it's going to be a decaying line, right? So what I would do is, we're looking at 2 times 1 over b to the x power. I would look for another point that we can get. So if y is equal to negative 7, well, let's, yeah. So when x equals, what we want to do is solve for the b here, right? So we know we could look at this point right here, and we know that not negative 7, it's a positive 7. We know that 7 is equal to 2 times b to the negative 1 power, right? Because x is negative 1 here. So all that means is that we are flipping it over. So 2 times b. So it's 2 times 1 over b to the negative 1 power. So we're going to flip it. So 7 is equal to 2 times b to the first power divided by 2. So b is equal to 7 over 2. And so, I mean, that's how you could do it. You can just look for the y-intercept. Like in this one here, your a value is going to equal 4. On this one, your a value will equal 3. We know it's increasing, so it's just going to stay as b to the x power. Y equals 3 times b to the x power. Let's look for another point. Well, right here. So 2 and 12. So y equals 12 when x equals 2. So 3 times b squared. Divide by 3, and we get 4 is equal to b squared. So b must equal 2. So then our actual equation is going to be y equals 3 times 2 to the x power. So do you see how you do it? Now, this kind of stuff's not going to be in your test. It might ask you to identify whether a graph is decaying or it might ask you to identify whether or not it's decaying or exponentially growing. But you kind of get the point here. So on this one, maybe yeah, I knew it was 2. So then, I think the point I should have used is this one here. So sometimes it's kind of hard to tell with these. Because then that would have been 8 divided by 2, which is 4, which means that 1 over b would equal 1 over 4. Yeah. Alright guys, so good luck on your test. Feel free to reach out to me, especially on here because I have lost access to you guys' Google Classrooms. So you can either email me, using the Mogador email, or reach out to me on this YouTube channel here if you want additional help on any of the review stuff. Good luck though, and I hope you guys are all doing alright.